Good morning, students. I welcome all the students present in this video lecture for the subjects of the internal combustion engine. In today's lecture, we are starting with chapter number 1, and that is the introductions. And basically, as per the curriculum of the GTU, we are going to discuss the comparisons between the SI and CI engine in this chapter. But before starting the comparisons between SI and CI engine, I start with some of the basic topics, and which is very familiar with all the students, as the basic of the internal combustion engine that you have learned in the basics of mechanical engineering as well as in the third semester engineering thermodynamics. So let's start with the topic that we are going to discuss in this chapter. So as per the curriculum of GTU, the chapter is comparisons of SI and CI engine, and the difference, or we can have to compare the SI and CI engines based on this given point. So the first point is given over here, that is the difference in thermodynamics and operating variables. So students, we have to compare the SI and CI engine basis on the thermodynamic and operating variables, where the second point is given, that is for the performance characteristics. The third point is given, that is initial and maintenance cost. And the fourth point in this subject is given, that is applications of SI and CI engine. So students, in today's lecture, we are going to discuss the various point or the various aspect in view with the thermodynamics and operating variables for both the engines, that is SI and CI engines. So before starting the discussions on the point 1, let me start with the classifications of IC engine. It is very basic topic, and all of you must have known that we can classify the IC engines based on the various aspects. So first, and classified the IC engine based on the fuel that is used in the engine. So the first is the petrol engine, because we are using the petrol as a fuel. Then second is the diesel engine, so we are using the diesel as a fuel in the engine. And third is gas engine. And sometimes in some references, it also mentions that the biofuels. Biofuel means they are operating on the two types of fuels. Then the second classification is nature of thermodynamic cycles. So first is Otto cycle, that is also called as a constant volume cycle. Then diesel cycle, that is called as a constant pressure cycle. And the third one is, we can say, the mix. It is a combination of heat supply at constant volume as well as constant pressure, or we can say it as a dual cycles. Then the third classification is for the number of strokes. So there are two types of the engines we can classify based on the number of stroke per cycle, and that is a 4-stroke and 2-stroke. If the cycle is complete in the 4-stroke, then we can say the 4-stroke engine, and if the cycle completes in the 2-stroke means there is a 1 revolution of crank, and 4-stroke means there is a 2 revolutions of crank. And as all of you know that there are 4-stroke engine, we have the suction, compression, combustion, or we can say exhaust stroke. Then the method of ignition, this is very important. The ignition is a very important part, and it is important phenomena for the combustions of the fuel inside the engines. So one is a spark engine, and short form of this engine we know it is the SI engines. And second is compression ignitions, and we called as a CI engine. So the mixture of air and fuel is ignited by electric spark. So we have the spark plug, and the spark is generated from that spark plug, and the combustions, or we can say the initiations of the combustion process of a fuel and air, we can say the petrol and air, is initiated by the spark, and that's why this kind of engine is called as a spark ignition engine. And in second, the fuel is ignited as it comes in contact with the hot compressed air. So student, as all of you know that in compression ignitions means the diesel engine, in the suction stroke, suppose I'm explaining you, this is a cylinder and here we have the piston. So from the suction valve only air is drawn, then it is comes in the compression stroke, and at the end of the compression means the temperature is reaches very high as well as the pressure and temperature is high. At that time, from this injector The fuel is sprayed inside the combustion chamber, or we can say the cylinders, and the combustion is take place, and that is not a single spark. It is the flame generated from many of the places, and in the spark ignitions there is spark plug is there, and flame is a single flame which is traveled in the cylinders, or we can say the combustion chambers. So this is the two method of ignitions is there, and basis on that we can classify the engine as a SI and CI. Then next classification is a method of cooling, and there are two methods of cooling is there. One is air cooled engines, and second is cooled engines. Then the speed of engines. So as per the speed, we can classify the engines in three categories. One is low speed, medium speed, and high speed engines. And the number of cylinders. If in engine only one cylinder is there, then it is called as a single cylinder. And if we have the more numbers of cylinders than the one, then we can say that these are multi-cylinders. Now classification is over here. In other books or in the references, there are lots of classifications are given, but right now it is not required over here to discuss more about the classifications of PC engines. Instead of that, we are going to discuss about the difference between the petrol and diesel engine, and sometimes it may be treated as SI engines and CI engines. And student, you also know about the basics point. So the works on petrol engine, we know that it is work on the Otto cycle, where the diesel engine is work on the diesel cycle. The second point is petrol is used, obviously it is petrol and diesel. Then the mixtures of air and fuels through the carburetors, it is coming in the cylinders, or we can say the engines, and here only air is thrown in the suction stroke. Low compression ratio is that is 6 to 10, and here it is 15 to 22, or sometimes in references it is given that 14 to 20. Here the spark plug is there, which is ignition devices, and here we are using the fuel injector to inject the fuel inside the cylinders. This engine is running at very high speeds, where the diesel engines are running at low speeds. The thermal efficiency is lower due to the lower compression ratio, and here it is higher due to the higher compression ratio. Lighter weight because the maximum pressure and the temperature is less, and here it is a heavier weight because the maximum pressure and temperature is high. Here, if we discuss about the cost, then it is less cost. Here it is more cost. Then maintenance cost is less, maintenance cost is slightly higher. Easier starting even in the cold weather, where it is difficult to start in the cold weather. Running cost is higher because petrol is costlier and diesel is cheaper than. But nowadays this difference is not that, because we know the price of the petrol and diesel is almost near about same. So we cannot able to write the last point, but it is given in the literature. That's why we have mentioned over here. That we start with the our today's topic. The first point given for the comparisons of SI and CI engines is the difference in the thermodynamics and operating variables. So student, under the category of this point, we have to discuss the difference in the thermodynamics and operating variables. So I have listed down the different 8 points on which we are going to discuss about the comparisons between SI and CI engines, and that one is the thermodynamic cycles. Then second is the combustion phenomena. Then third is compression ratio. Fourth one is operating pressures. Then fifth is operating speeds. The sixth one is the distribution of fuel between the cylinders. And seventh is exhaust gas temperature. And last one is starting phenomena of SI and CI engine. So in today's lecture, we will discuss these 8 points for the comparisons between SI and CI engine. So now we are going to start with the first point, that is the thermodynamic cycles. So students, for SI engine, we also know that it is a petrol engine, and the operating cycle for the petrol engine is an Otto cycle. And as we know that in the heat cycles, we have the 4 different processes. Suppose if I am going to plot the PV diagram Then we have the variations. There is the constant volume cycle is there. So these are lines, the vertical lines are indicating the constant volume cycles or constant volume processes. And these lines are indicating the rises in the pressure. Suppose we mark this point is a point 1. So this point is indicating the pressure is increases, and if the pressure is increases, simultaneously the volume is also get decreases. Let where this is the V1, this is the V2, and we can write this 0 point over here. The point 0 to 1, we can write this is the increasing the volume, or we write over here it is the top dead centers. This is the bottom dead centers. And suppose we have the cylinders, then it is like this. We just show the piston. This is the clearance volume. Here we have this valve. We also have the spark plug. 0 means O to 1 is a suction. So piston is moving from top to bottom. It is a suction stroke. Then from 1 to 2, it is the compression and pressure increases. From 2 to 3, at constant volume, the heat is supplied. So when piston is reaches to the top dead center again, the spark is there, and due to this spark, the flame is propagated in this cylinder, and by burning of fuel, the pressure is generated, and under this action of pressure, the piston is moving towards the top to bottom. So from 4 to 1 is the expansion, or we have work output is there. So we have W output. Here compression is, so it is W in. And then for the output, after that, after reaching to the BDC, exhaust valve is open and all the gases are exhausted from the exhaust valve, and the heat is rejected, means exhaust gas is there, and again there is 1 to O motion is there, and from O to 1 the cycle is repeated. So this is the working of the petrol engine, and we write as the Otto cycles. Now for the diesel cycle, we know that the working cycles, let me write that is the CI engines. This is also known as a diesel engine because diesel is used as a fuel. Diesel cycle is that, and which is also known as a constant pressure cycle. So again we plot the PV diagram. The horizontal line is indicating the constant pressure lines. Vertical line is indicating constant volume lines, and this kind of the then this is again we have the top dead centers. This is the bottom dead center. O to 1, there is a suction. 1 to 2, this is 2, this is 3, this is 4, and 4 to 1. And this volume we can have, or we can treat as a clearance volume. Similarly, we have this phenomena. So we consider the cylinder, and we represent the piston at top dead centers. There the exhaust valve, suction valve, and here this injector is there. Now students, similarly 0 to 1 is the suction, or we can have the exhaust. Then 1 to 2 is the compression, and we supply the work for the compression of gas. Here in the Otto cycle, at the beginning of the suction stroke, or at the starting of suction stroke, the air plus fuel, that is called as a petrol, this mixtures is enter inside the cylinders. But in diesel engine, the suction, so only air is there, no we add any kind of fuel droplets with the air, so only air is having enters in the cylinders. And then at the end of the compression stroke, at the point number 2,
we start the injections of the diesel or the fuel is there, and that's why this volume is occurs. And here we have one word that we called as a cut off. So this is the total length of the stroke. This is, we can say, the stroke length, and out of the stroke length, that much amount of the length we supply the fuel, and at this V3 we cut off the supply of fuels. Means at the exactly at the top dead center, when the piston is reaches to the top dead center, the diesel injection will take place from this injector, and it will inject till the point of 3, and after that the fuel supply is off, and that's why this phenomena at point number 3 is known as a cutoff phenomena. And then from 3 to 4 there is the expansion, and in expansion phenomena we get the W output, that is the work output from the system. And here there is a heat rejection is that is a QR, and here we have this Q as that heat is supplied. And sometimes in practices for the high speed diesel engine, the system used or the working cycle used, that is also known as a dual cycle. So we can write that operating cycle for the CI engine is diesel or dual cycles. In dual cycle, there is the partial heat is supplied at constant volume and partial heat is supplied at constant pressure, and the heat rejection is take place at constant volume. So this kind of cycle diagram is that. So it is the combinations of Otto as well as diesel cycle, and this kind of cycle is known as a dual cycle. Dual cycle is used for the high speed diesel engines. So this is the operating cycle, or we can say the thermodynamic cycle difference between the petrol and diesel engine, or SI and CI engines. Now students, we go for the important point. We compare these two cycles for the some parameters, and that is the first parameter is the compression ratio. The second is the amount of the heat supply. So amount of the heat supply, that is represent as a QS. The compression ratio we know as a CR. If we compare the efficiency of petrol engine and diesel engine, then for the same compression ratio, let me write same compression ratio, and for same amount of heat supply, the efficiency of the Otto system is greater than of efficiency of diesel. But we know that in the practice or in the actual, this is theoretically we have discussed, but in the practices we know that in the diesel engine the value of compression ratio is more than in the range of 40 to 22, where in the case of petrol engine it is in the range of 7 to 10. So in practical life, the efficiency of the diesel engine is greater than of efficiency of petrol engine. This is the final conclusion. In the practical applications, diesel engine has a more efficiency compared to the petrol engines. Then the second is combustion phenomena. So in SI engines, there is a spark plug is there, or spark ignition is there. So there is a single flame is there. Let's suppose this is the cylinder and we have this spark plug over here. This is the spark plug. So at the end of the compression stroke, piston is reaches to the top dead centers, and here there is the mixtures of petrol and air is there. So it is the mixtures of petrol plus air, and from the spark plug only one spark is generated, and that is spread throughout the homogeneous in the cylinder. So there is only a single flame is there and which is traveled, and this combustion we can say that it is a homogeneous. But wherein the CI engine at the end of the compression stroke, when piston is reaches to the top dead center, here we have the nozzle, and we can say that it is the injector. Here it is only air is there. So let me explain you over here. See, this is the very big environment, or we can say the clouds of the air, and it is end of the compression stroke. So it creates the higher pressures. As you know that the high pressure is there, and pressure is directly proportional to temperature. So pressure is increases, the temperature is increases. So this is, we cannot write as a air, it is a hot air cloud is there, and which has a temperature beyond the burning temperature of the diesel. So suppose this is a hot air, and now let me explain you the droplets of fuel using this green line. So from the nozzle, like from the center, the nozzle is there, and nozzle is spraying the droplets of diesel in this cloud of hot air, like this. And at this, all the droplets are simultaneously burn, means there is the flame is propagating from all the droplets, because this is very high temperature, hot air is there, and the starting of the burning of all these droplets are there in the cloud of hot air. So there is lots of amount of the flames is propagate inside the cylinders, where in the spark ignition only the single flame is propagate in the uniform, or we can say the homogeneously throughout the cylinders. But here heterogeneous combustions is take place because of the spreading phenomena of this, or we can say the spraying phenomena of the diesel fuels. So this is, there is no single flames is possible in the CI engine, where in the petrol engine only the single flame is propagated inside the cylinders. Now we are moving towards the next point, that is a compression ratio. So as we know that in SI engine there is a low compression ratio, it is in range of the 7 to 10, where in the CI engine there is a high compression ratio, which is in the range of 14 to 22. And why we require the higher compression ratio? Because we know that we reach to the high temperature for burning of the diesel fuels, and diesel is burning at very high temperature. To have the high temperature, we have to go for the higher pressures, and that's why the compression ratio in the diesel engine is higher compared to the petrol engines. So this is the and we can also write the conclusion over here that CI engine has a higher thermal efficiency of high value of CR, or compression ratio. Now we are going for the operating pressures. So in operating pressures, we know that the value of operating pressures in the CI engine is near about 30 to 50 bar. It is also in line with the compression ratio, where in the SI engines we have the pressure that is 7 to 15 bar. And due to this point, the higher pressure, we require the material strength high in diesel engine, and that's why the weight of diesel engine is high compared to petrol engines. And if we write also the one relation, that compression ratio of CI engine is 3 to 4 times the CR, or the compression ratio of SI engines. So this is very important formula. Sometimes it is asked in the MCQ types of examinations or in the competitive exam, that what is the range of the CR ratio of diesel engine or CI engines compared to SI engines. And we can also write that maximum pressures of the CI is 1.3 to 1.4 times of P max of SI engines. Now we are moving towards the operating speeds. The operating speeds is depends on the brake horsepower. So we write as a bhp, that is called as a brake horsepower, or we can generally treat as a rating of an engine or output of engine. And this bhp is the functions of the speeds. So maximum bhp, you get the maximum speed, or we can write the n, we just indicated it as speeds. So we know that the diesel engine is having the less bhp, and that's why the minimum amount of the speed is there. So SI engine has a maximum speeds than the CI engines. Now we are moving towards the distributions of fuel between the cylinders. Students, this is very important topic. Let we take the multi-cylinder engines. Suppose I am taking the 4-cylinder engines. Suppose this is my fuel tank, and from that it is carburetor, so air is supplied, here it is a fuel is there, then the mixture is supplied to the different engines. But in the petrol engine there is device is called as manifolds. So manifold is there, and from the manifold the fuel is supplied to the different engines. So what exactly happens when the first engines or the first cylinders is comes, the larger droplet size is supplied to over here. So as you progress, the last cylinder, so let me take this is the first, this is second, this is third, and this is the fourth. So at the fourth cylinder, when the mixture is reaches, the proportions of petrol and air gets different. So as the mixtures of petrol and air is going over here, the first cylinder is having the rich mixtures and the last cylinder having the lean mixtures. So we cannot have the optimum value of air fuel, and due to which we have differences in the stoichiometric ratio also, and this is creates the various difficulty for the maintaining the performance of an engine's cylinders. Where in diesel engines we do not require to supply the air and petrol mixtures. There is one injector. An injector is having the same line of fuel supply. So due to that, the fuel nozzles, the ratio of proportions for air and fuels is similar in all the engines. Where in the petrol engines, we cannot have the air fuel ratio same in all the engines. So this is the problem, or this is the comparisons of distributions of fuel between the cylinders in petrol engine and diesel engines, means in SI engine and CI engines. Now the exhaust gas temperature, this is the 7th point. So exhaust gas temperatures, we know that the CI engine and SI engines, we know that the efficiency of CI is greater than of efficiency of SI. So heat supply is majorly utilized in the CI engines. So for the exhaust, the low amount of heat is there, so lower the exhaust gas temperature is there in the CI engines. Where in SI engines, the higher exhaust gas temperature is there because the efficiency of SI is low compared to CI. So high exhaust gas temperature is there. And if you further supply the excess air in the CI engine, which also leads towards the lower in the exhaust gas temperature. So we can compare that the CI engine has a higher efficiency, and that's why the lower exhaust gas temperature, where in the SI engines it has a lower efficiency, and that's why the higher temperature in the exhaust gas is observed. Then for the starting, as you know that petrol engine is start in any of the weather conditions very easily. So SI starting is very easy in the every season, but where the CI is difficult, because for the combustions of the diesel we require the higher temperature, and for the higher temperature we have to go for the higher compression ratio,
and higher compression ratio cannot be achieved easily. And even in diesel engine only air is there and which is drawn from the atmosphere, so in cold weather the temperature of air is very less, and due to which we have to go for further increasing in the compression ratio, and then we achieve the higher temperature and then the engine will start. So for the cold starting of CI engine or the diesel engine is very difficult because only air is drawn in the suction stroke. And that's why we can conclude over here the SI engine can easily start in any season where it is difficult to start the CI engines, in especially in cold seasons or cold weathers. So this is the comparison points between the CI and SI engines basis on the thermodynamic and operating variables. And this is the end from my side. So first point on the chapter 1 is over here, that is a difference between the SI and CI engine basis on the thermodynamics and operating variables. In next lecture we are going to discuss about the second points and third point. So this is end from my side. Thank you for attending this lecture.